Welcome all. Let's go with today's session, that is AOA introduction. Today we'll know how AOA is basically done between two FIRA devices. And then we'll introduce on some of the frames that is used in a two-way ranging, and then get to know typically what is AOA elevation and azimuth definitions. Angle of arrival is based on phase difference of arrival method, which is typically called PDOA method. And in two-way ranging, PDOA calculation is done using phase difference between the two antenna of a received signal. So generally when you have to do AOA, you use two antennas, and care should be taken in such a way that these two antennas are spaced out on the hardware at lambda by 2. So which is near to 18.8 mm for a channel line as an example. Now in this picture what you see is that there are two antenna on a mobile device, and if you just zoom out, the actual physical placement that you see, the D is actually the lambda by 2, and then there is an anchor over here where there are series of request response signaling is done. When the response message is received on the phone RX1 and RX2, there is always some difference. The next slide we'll see how angle of arrival in principle is calculated. Now, if you consider a radio signal sent from a distance transmitter which arrives at two antennas, it can be seen from the geometry depicted here. You have RX1 and RX2, they are spaced at distance D. Then the signal coming to RX1, signal coming to RX1, there is a path difference that is denoted as P. Now, if you see the typical sine wave over here, the angle of arrival is then calculated with lambda is equal to 2 pi c by f, which is f is the carrier frequency and c denotes the speed of light. And then delta t is the time difference between the signal arriving at two antenna. Now, if you take a look at this equation and then you transpose, then you finally arrive at this method to calculate the theta, which is the angle of arrival from that particular anchor. In a two-way ranging, the way you can do angle of arrival for an IEEE frame is you can also look into the final message that is from the initiator. So you have typical RCM, pole, response, final and final data. On a responder side, when it receives the final message, it can then look into the IEEE frame and then calculate the PDOA and then arrive at the angle of arrival. When we talk about angle of arrival in a 3D space involves both elevation and azimuth. Here on a phone, when you hold a phone to your face with the screen in a portrait mode, the x-axis is the horizontal display axis of the phone, then the y-axis is the vertical display axis on the phone, then the z-axis is the orthogonal to the phone's display. And the definition of elevation is that elevation angle is the relative angle between the exit plane and the incoming signal. So in this direction, if there is an incoming signal from the target, the elevation is calculated between x and z angle. Then azimuth angle is the relative angle between the z-axis and the incoming signal projected on the exit plane. It is 0 on the z-axis, it is positive towards the x in clockwise direction, and it is negative towards the x in the counterclockwise direction. Right? So that is how AOA azimuth is calculated. So this is about today's introduction on AOA. Thank you all for watching, and if you want to learn more, please visit FIRA webpage for details. Thank you.